Okay, simplifying expressions with fractional and negative exponents. Here we go. In general, a to the power of negative x over y will give you 1 over that base to the positive x over y in index form. In radical form, it's 1 over a to the power to the y root to the power of x. That's index form there, and that's radical form here, also called surd form. Now let's do some examples where we rewrite them in radical form. And a to the negative 3 over 4 equals, we'll figure that out, 5a to the power of negative 7/3 equals. Let's start with the first one. X to the negative 1/2 means 1 over x to the positive half. And positive half exponent is the square root of x, 1 over square root of x. 1 over y to the positive 2/3 equals 1 over y to the third root to the power of 2. A to the negative 3/4 means 1 over a to the positive 3/4, which equals 1 over a to the fourth root to the power of 3. Finally, 5 is a coefficient, nothing happens there. 5 over a to the positive 7/3, which means 5 over a to this third root to the 7th power. Okay, all of those are in radical or surd form. And let's try the other way around, rewriting in index form, which we will use for calculus. 1 over square root of x to the 5th. Now remember that square root has an invisible 2 in there. Okay, right there. So square root, we don't usually write the 2 there. So that means 1 over x to the 5/2. Okay, now since that 5/2 is in the bottom, it's going to be a negative exponent, x to the negative 5/2. Next one, 2 over that radical is going to be 2 over x to the 3/4. Okay, now that's going to be 2 to the x to the negative 3/4 when we get it out of the denominator. All right, so these are important examples here, and let's take another look at all of those. Okay, radical form on the right, index form on the left. Now here we want to simplify to radical form. 1 over x to the negative 1/4. Negative on the bottom means positive exponent on the top. So it's going to equal x to the positive 1/4, which equals the fourth root of x. Okay. Next one. Fraction to a negative power will equal the reciprocal to the positive power. Okay. So that's a general rule that we'll write down in a minute. Now what I'm going to do is I'm going to write it in radical form. That's going to be 4x over 9 cubed. And square root, I don't need to write that 2 right there. Okay. Now square root. Now I'm going to cube everything, every part of that fraction. 4x cubed is 64x cubed. And 9 cubed is 9 times 9 times 9, 729. All right. Now when I square root a fraction, I square root the top and I square root the bottom. Now the square root of 64x cubed is 8 with x cubed left under the radical, and 729 is a square number, I think, 27. Okay, done and dusted there. Next one, 5x to the negative 5/3. What does negative 5/3 mean? It means it's going to go on the bottom to the positive power, 2x to the positive 5/3. Okay, now 5 doesn't change. Let's write that in radical form. That's going to be x to the third root to the power of 5. All three of those are in radical form. I'm going to come up with a general rule here when I take a fraction to a negative fraction power. Okay, a fraction, so let's say I've got a over b and I'm raising it to negative x over y. It doesn't matter what it is. It's going to equal the reciprocal to the positive power. Okay, and that's going to be handy to know. That's a good little shortcut there. Let me just show you a number example. Let's not even do algebra. Let's look at a number example. I'll just pick a fraction, 4/9 to the negative 3/2 power. What does that mean? It means it's going to be the reciprocal, 9/4, to the positive fraction, 3/2. Okay, and what's that going to equal? Well, now I'll put it in radical form. That's going to be a square root, 9/4 cubed. Okay, so I'll cube everything in there. 9 cubed is 729. That looks familiar. 4 cubed is 64, I think. Both of those are square numbers. 20 square root of 729 is 27. Square root of 64 is 8. Great. All right, it's starting to make sense. Let's look at some hard examples. Here we go. Look at these. Lots of fractional exponents. Hey, multiplying powers. I add these exponents. Negative 1/2 plus 1/4 is negative 1/2. Down here, 3/8 and 2. I'm going to add those exponents. 3/8 plus 2 gives me 19/8. Division of powers. What do? I subtract the exponents. So I do negative 1/4 minus 19/8 gives me x to the negative 21/8. Hey, I could leave it like that if I want to. You know, that's fine. I didn't say what form to put it in. Or I could put it in radical form. 1 over x to the 21 to the 8th root. I circled that one because that's more calculus friendly. This one, hard stuff. Look at this. Okay, let's take everything to the third power. 27 to the third power. And now here, power to a power gets multiplied. 3/4 times 1/3 is 1/4. Okay, and I'm just going to simplify that first before I look at the next bit. 27 to a third is 3. And nothing there. Now times that second bit here. 9 to the power of negative 1/2. 9 to the power of negative 1/2. Figure that out in a bit. Times power to a power gets multiplied. Negative 3/2 times negative 1/2 equals 3/4. Well, let's rewrite this first expression. 3a to the power of 4 times, what's 9 to the negative 1/2? What does that mean? It means 1/3 times a to the power of 3/4. So I'm going to multiply this big mess together. It's not a mess. 3a to the power of 4 over 3, because that's times 1/3. Get it? Times a to the power of 3/4. Okay, 3's cancel out. That's great. So I just get a/4 times a to the power of 3/4. Multiplying powers, I add the exponents. 4 plus 3/4 is a to the power of 1. All of that work. And my simplified expression is just a. Let me rewrite this part because I didn't do that in the original working. A bit rushed. 9a to the negative 3/2 times to the power of negative 1/2. I forgot to do that, and everything else gets simplified. Good luck!